Picture this. You're sitting in an exam, staring at a quadratic equation, and your mind goes completely blank. Why are quadratic equations so tricky? And how can we master them once and for all? In this video, we'll unlock the secrets by mastering the three essential forms of quadratic equations: standard form, factored form, and vertex form. These forms aren't just abstract math. They unlock solutions to real-world problems like calculating the perfect trajectory for a basketball shot or finding the optimal dimensions for a garden. By the end of this video, you'll confidently convert between these forms and solve any quadratic equation that comes your way. A quadratic equation is a polynomial equation of degree 2. This means the highest power of the variable is 2, which gives these equations their characteristic curved shape when graphed. The general form of any quadratic equation is ax squared plus bx plus c equals 0, where a is not equal to 0. Each letter in this equation represents a specific coefficient. The letter a is called the quadratic coefficient and determines the shape and direction of the parabola. The letter b is the linear coefficient, which affects the position of the vertex along the x-axis. Finally, c is the constant term, which represents the y-intercept of the parabola, where the graph crosses the y-axis. An important characteristic of quadratic equations is that they have at most two solutions, which we call roots or zeros. These are the x values where the parabola crosses or touches the x-axis. Understanding this foundation will help us explore the different forms of quadratic equations and learn how to work with them effectively. The standard form is the foundation of quadratic equations. Understanding this form is crucial because it gives us direct access to the coefficients we need for solving quadratic equations using various methods. The standard form of a quadratic equation is written as ax squared plus bx plus c equals 0. This is the most common way to write quadratic equations, and every quadratic can be rearranged into this form. In this form, we have three important parts. The letter a is called the quadratic coefficient. It's the number in front of x squared. The letter b is the linear coefficient, the number in front of x, and c is the constant term, the number by itself. There's one crucial requirement. The coefficient a cannot be 0. If a equals 0, then we don't have an x squared term, which means it's not a quadratic equation anymore. It becomes a linear equation instead. Now let's look at a specific example to see how we identify these coefficients in practice. Here's our example equation. 2x squared plus 5x minus 3 equals 0. We need to identify the values of a, b, and c from this equation. First, let's identify a, the quadratic coefficient. Looking at our equation, the coefficient of x squared is 2, so a equals 2. Next, we find b, the linear coefficient. The coefficient of x in our equation is 5, so b equals 5. Finally, we identify c, the constant term. In our equation, the constant term is -3, so c equals -3. Notice that we include the negative sign as part of the coefficient. So from our equation 2x squared plus 5x minus 3 equals 0, we have successfully identified that a equals 2, b equals 5, and c equals -3. Understanding standard form is essential because these coefficients a, b, and c are used in many important quadratic equation techniques. They're needed for the quadratic formula, calculating the discriminant, factoring, and completing the square. The standard form gives us a systematic way to organize any quadratic equation, making it ready for whatever solution method we choose to use. This is why mastering the identification of coefficients in standard form is so important for success with quadratic equations. Now that we understand standard form and how to identify coefficients, we're ready to explore other forms of quadratic equations. Now we'll explore the factored form of quadratic equations. This form is incredibly powerful because it directly shows us the solutions to the equation. The general factored form of a quadratic equation is a times the quantity x minus r times the quantity x minus s equals 0. In this form, the letter a is the leading coefficient, just like in standard form. The letters r and s represent the roots or solutions of the equation. The roots r and s are also the x-intercepts of the parabola when we graph the quadratic function. This form makes it easy to identify where the parabola crosses the x-axis. Let's work with a specific example to see how this works in practice. Here we have the equation x minus 2 times x plus 3 equals 0. Notice that a equals 1, r equals 2, and s equals -3. From this factored form, we can immediately see that the roots are x equals 2 and x equals -3. We get these by setting each factor equal to 0. Setting the first factor x minus 2 equal to 0 gives us x equals 2. Setting the second factor x plus 3 equal to 0 gives us x equals -3. Now let's see how to expand this factored form back to standard form using the distributive property. We start with our factored form and use the distributive property, also known as FOIL, to multiply these binomials. Using FOIL, first we multiply the first terms x times x, then the outer terms x times 3, then the inner terms -2 times x. Finally, the last terms -2 times 3. This gives us x squared plus 3x minus 2x minus 6. Combining the like terms 3x and -2x gives us our final standard form, x squared plus x minus 6 equals 0. Let's summarize what we've learned about factored form. The factored form directly reveals the solutions by setting each factor equal to 0. These solutions are the x-intercepts, where the parabola crosses the x-axis. We can always expand the factored form using the distributive property to get back to standard form. Understanding factored form is crucial because it provides the most direct path to finding the solutions of a quadratic equation. In our next section, we'll explore the vertex form, which reveals different important information about quadratic functions. Now we'll explore the vertex form of quadratic equations. This form is incredibly useful because it directly reveals the most important point on the parabola, the vertex. The vertex form has three key components. The coefficient a controls how wide or narrow the parabola is and whether it opens upward or downward. The value h represents the x-coordinate of the vertex. Notice that in the equation we have x minus h, so the vertex occurs at x equals h. Finally, k represents the y-coordinate of the vertex. This tells us the maximum or minimum value of the quadratic function. The vertex coordinates are simply the point hk. This makes vertex form extremely convenient for graphing parabolas. Now let's work through a specific example to see how this works in practice. Consider the equation 2 times the quantity x minus squared plus 4 equals 0. We can identify the vertex directly from this form. Step 1. We need to identify the values of a, h, and k by comparing our equation to the standard vertex form. From our equation, we can see that a equals 2, h equals 1, and k equals 4. Remember, even though we see x minus 1, the h value is positive 1. Step 2. Now we can immediately write down the vertex coordinates. The vertex is at the point 1, 4. This means the parabola reaches its minimum or maximum value of 4 when x equals 1. Now let's discuss what the coefficient a tells us about the parabola's direction. The sign of the coefficient a determines which direction the parabola opens. If a is positive, the parabola opens upward like a smile. If a is negative, it opens downward like a frown. In our example, since a equals 2, which is positive, the parabola opens upward. This means the vertex at 1, 4 represents the minimum point of the parabola. The vertex form makes it incredibly easy to identify the key features of a parabola. You can immediately see the vertex coordinates and determine whether the parabola has a maximum or minimum value. Now we'll work through our first example of converting a quadratic equation from standard form to factored form. This is a fundamental skill that will help you solve quadratic equations efficiently. Here's our quadratic equation in standard form. X squared plus 5x plus 6 equals 0. Our goal is to rewrite this equation in factored form. Factoring means we want to write our quadratic as a product of two binomials. The general form looks like this. X plus a times x plus b equals 0. Now I'll show you the key strategy for factoring. We need to find two special numbers. Here's our key strategy. We need to find two numbers that satisfy two conditions. First, they must multiply together to give us 6. Second, they must add together to give us 5. Notice where these numbers come from. The 6 comes from our constant term, and the 5 comes from the coefficient of our x term. Now let's find these two numbers by testing different factor pairs of 6. The factor pairs of 6 are 1 times 6 equals 6, and 2 times 3 equals 6. Now we need to check which pair adds up to 5. Let's check the sums. 1 plus 6 equals 7, which is not what we want, but 2 plus 3 equals 5, which is exactly what we need. Perfect. Our two numbers are 2 and 3. Now we can write the factored form. Here's our factored form. X plus 2 times x plus 3 equals 0. Notice how we use our two numbers, 2 and 3, as the constants in each binomial. Now we can find the solutions to our equation. Since we have a product equal to 0, we can use the zero product property. The zero product property tells us that if a product equals 0, then at least one of the factors must equal 0. So either x plus 2 equals 0 or x plus 3 equals 0. Now we solve each equation separately to find our final answers. From x plus 2 equals 0, we subtract 2 from both sides to get x equals negative 2. From x plus 3 equals 0, we subtract 3 from both sides to get x equals negative 3. Therefore, our solutions are x equals negative 2 and x equals negative 3. These are the x values that make our original quadratic equation equal to 0. We can verify these solutions by substituting them back into our original equation. Both values will make the equation true, confirming our factoring was correct. Now we'll learn how to convert a quadratic equation from standard form to vertex form using a powerful technique called completing the square. This method allows us to transform any quadratic into a form that immediately reveals the vertex of the parabola. Completing the square is a method where we take a quadratic expression like x squared plus bx and transform it into a perfect square trinomial. The key insight is that we can rewrite this as x plus b over 2, all squared, minus b over 2 squared. Let's work through a specific example. We'll convert x squared plus 4x plus 1 equals 0 from standard form to vertex form. Our goal is to rewrite this in the form a times x minus h squared plus k equals 0, where the vertex will be at the point hk. Step 1. We need to isolate the x terms on the left side. We move the constant term 1 to the right side by subtracting 1 from both sides. This gives us x squared plus 4x equals negative 1. We do this because completing the square works best when we have only the x squared and x terms on one side. Step 2. Now we complete the square. To do this, we take the coefficient of x, which is 4, divide it by 2 to get 2, then square that result to get 4. This number, 4, is what we need to add to both sides to create a perfect square trinomial. Now we add 4 to both sides of the equation. Starting with x squared plus 4x equals negative 1, we get x squared plus 4x plus 4 equals negative 1 plus 4. Simplifying the right side, we have x squared plus 4x plus 4 equals 3. Step 3. Now we can factor the left side. We recognize that x squared plus 4x plus 4 is a perfect square trinomial. It factors as x plus 2 all squared. This gives us the equation x plus 2 squared equals 3. This step works because we specifically chose to add 4 to create this perfect square pattern. Step 4. To get the standard vertex form, we subtract 3 from both sides. This gives us x plus 2 squared minus 3 equals 0. This is now in vertex form, which follows the pattern a times x minus h squared plus k equals 0. Here's our complete transformation. We started with the standard form x squared plus 4x plus 1 equals 0 and converted it to vertex form, x plus 2 squared minus 3 equals 0. To identify the vertex, we compare our result with the general vertex form a times x minus h squared plus k equals 0. In our equation, a equals 1, h equals negative 2, and k equals negative 3. Therefore, the vertex is at the point negative 2, negative 3. Completing the square is powerful because it creates a perfect square trinomial that's easy to factor. This method directly reveals the vertex coordinates and shows us exactly how the parabola is shifted horizontally and vertically from the origin. Most importantly, this technique works for any quadratic equation, making it a universal tool for converting to vertex form. Remember, our final answer shows that the vertex of the parabola x squared plus 4x plus 1 equals 0 is located at the point negative 2, negative 3. This completing the square method is essential for understanding quadratic functions and their graphs. Today we've covered the 3 essential forms of quadratic equations and how to convert between them. This knowledge is fundamental for solving quadratic problems and understanding their geometric properties. We explored the standard form, which is the most common way to write quadratic equations with coefficients a, b, and c. We learned about factored form, which immediately shows us the roots or x-intercepts, of the quadratic equation. And we discovered vertex form, which reveals the vertex coordinates and makes graphing parabolas much easier. Most importantly, we practiced converting between these forms using factoring techniques and completing the square. These skills will serve you well in algebra and beyond. If this video helped you understand quadratic equations better, please give it a thumbs up and subscribe for more math tutorials. In upcoming videos, we'll explore how to solve quadratic equations using the quadratic formula and discover real-world applications in physics and engineering. Remember, mastering quadratic equations takes practice. Work through problems regularly, and don't hesitate to review these conversion techniques. You've got this. Keep practicing, and you'll master quadratic equations in no time.